Intel, they're launching two new CPUs in just a few days. The Core Ultra 7 270K Plus and the Core Ultra 5 250K Plus. So what's the plus? More cores, aggressive price point, significant BIOS and platform updates, a new binary optimization tool. But these CPUs are launching into one of the worst periods in history for PC enthusiasts, where it's basically a wasteland, and there's significant competition for your gaming CPU dollar. How are you going to get memory and storage? So, seeing the numbers and what I have to say, after this, will you be nonplussed? So first off, this is one of the best announcement videos that I've ever seen in the entire history of the company, if you didn't see the announcement video just about a week ago. Intel's launching the 5 and 7 class CPUs, nothing to replace the 9, nothing to directly take on AMD's gaming crown with the X3D CPUs. Instead, they're going straight after the $200 to $300 price point with these CPUs. And honestly, that's probably the right move. I mean, in the theme of bottom line up front for this video, these CPUs are strong contenders. In my opinion, one of those reasonable CPU launches that Intel has ever done, certainly at least since Alder Lake, maybe even before that. These CPUs seem to use a little bit more power at the wall compared to AMD's price analog counterparts, but, you know, even a little bit more than the Intel predecessors, but we'll talk more about that. Now, don't get me wrong, they're still both 125 watts TDP like their immediate predecessors, which means 250 watts in Intel speed. But the 270K Plus now has a base clock of 4.1 gigahertz on the P cores and 3.4 gigahertz on the E cores. The 260 Plus, on the other hand, does 4.4 on the P cores and 3.7 on the E cores. So that's pretty good. Related to power, the boost behavior and single thread performance is more consistent and higher and stable, like much more stable, and I attribute that to the higher power usage, or I attribute the higher power usage to that functionality, and it's a more consistent end user experience. 4 more E cores. Yeah, you also get 4 more E cores in the Plus models. 6 P cores and 8 P cores and 6 P cores for the 7 and the 5, but they each get more E cores, so it's not really knocking power consumption at all since you got more cores. They're launching at $299 for the 270K and $199 for the 260K Plus. Because the 6-core CPUs have basically been on life support this whole time, Intel's basically finishing off 6-core CPUs. The value here is really good. You shouldn't buy a 6-core CPU. I've also included in our comparisons the Ryzen 9 9900X because it's about $360 on the street, which is well below MSRP. 12 cores, 24 threads. Maybe there's a comparison there. Gaming performance is strong. Multi-core and creative workloads are generally excellent. AMD still manages to pull ahead in a few games, but Intel's binary optimization tool makes a bigger difference than I expected. But which games you can use that with is also limited. We've got to talk about that in depth. But first, let's get to the results, because everything else I have to say will only make sense in context if you see what I see and we take a look at the actual performance numbers in comparison. So let's do that. Okay, let's start with artificial benchmarks, because this sets the stage for some of the anomalies that I'm going to talk about. And they're not really anomalies, but just behavior that you wouldn't necessarily expect. 8 to 64. And so I've grouped the results here to make it a little easier to read. This is more work than just screenshots, but hey, I'm doing it for you. Okay, 9700X and 9900X on the top versus the 250K Plus and the 270K Plus on the bottom. Look at that, over 100 gigabytes per second read memory bandwidth and 91 gigabytes per second write memory bandwidth. 8064 is not a perfect program for doing this, but it's good enough. We've got pretty good latency across the board here. I'm not sure why, but the Core Ultra 5 latency with the 7200 memory that was provided generally is less. Why is the Core Ultra 7 270K Plus 81 nanoseconds? The latency is a little higher. This, I think, will impact some gaming benchmarks that we'll look, but overall, you know, this is looking pretty good. The L3 cache latency here on the 9700X and the 9900X, 10 nanoseconds versus 20. There's probably some gaming benchmark differences there also. So what about CPU-Z? CPU-Z is, I mean, it's just, single thread performance, 889, 846, 850, 853. This is very similar single thread performance across all of these for something like general real world-ish, not really, sort of, kinda, like CPU-Z. And of course the Core Ultra 7 270K Plus takes the multi-core win here because it's truly 24 cores. Even versus our 9900X, you know, the Core Ultra 5 pulls ahead because 12 cores. Hyper-threading doesn't really help you in this CPU-Z benchmark. Cinebench 23 and 24 is largely the same, although the 9900X does pull ahead of the little Core Ultra 5 250K Plus, which, you know, the E-cores are not the same, they're not as good as full cores, like full P cores, but I think Intel was being really careful not to have a Core Ultra 5 product with 8 P cores, so that makes sense to me. And then the Ryzen 7 9700X here at 19,000, the 9600X would be even more anemic. And for single thread performance, it's very similar performance across the board here. Interestingly, the 9700X pulls ahead of the 9900X in single thread performance by just a hair, but this is overall, again, this is not an unexpected result. Our Core Ultra 7 Plus at 2640, you know, again, this is basically what's expected. Oh, I should say the AMD systems here are running DDR5 6000, but they have better cast latency. They're running at 26 cast latency, which is absurd. Let's look at Geekbench CPU. Again, this is a breakdown pretty much like you'd expect. And the Core Ultra 5 and the Ryzen 9 9900X, these are really close in performance here, with the 9700X falling behind because it's only 8 cores and 16 threads. This performance parity between the Core Ultra 5 and the Ryzen 9 9900X is a little more like what I expected to see across all of the benchmarks, even like gaming benchmarks, but you'll see that wasn't really the case. The OpenCL performance is a little odd just because the Core Ultra 7 270K Plus falls behind the Core Ultra 5 250K Plus. And this may be just down to platform latency and some other features. I'm not really sure. And if we look at creator workloads, Lightroom Classic, the 270K Plus is on top. The Core Ultra 5 and the 9900X are very similar. The Core Ultra 5 is pulling ahead. And keep in mind, the 9900X typically $60 more even when it's on sale. So the Core Ultra 5 here is sort of the value champion, coming in at over $100 less. It's like $150 less for creative workloads. And then you've also got Intel support in the Adobe suite, which historically has been better than the AMD support. Even though AMD has the hardware options and the hardware decoder, it seems that Adobe really just wants to support Intel. And Intel QuickSync, you know, the legend that is Intel QuickSync, may be the reason for that. And that comes through in Lightroom Classic. Photoshop, on the other hand, the Intel CPUs fall a little behind. I'm not really sure why that is. The 9700X comes out on top, even ahead of the 9900X in Photoshop in this particular Puget benchmark, and I don't really know what to make of that. Premiere Pro, the breakdown is more like I would expect. The 270K Plus, the 9900X pulls a little ahead, then the Core Ultra 5, and then the 9700X. This is basically in raw compute order. We'll start with an older title like Deus Ex Mankind Divided. 227 FPS, it is pulling well ahead of our other options, the Core Ultra 5 option as well as our options from AMD. But notice the performance really is pretty similar. On Deus Ex Mankind Divided, because Windows Scheduler isn't that great, our 1% lows are not as good as they should be because of scheduling issues. Now you can install like the core parking thing, you can install the AMD drivers to try to keep the game from moving off of one CCD, because remember the 9900X is 2 6-core chiplets. And this kind of a thing happens when one of the games moves across the chiplet. And you can fix that to varying degrees of success with software, kind of like Intel software can help its CPUs manage things between the P cores and the E cores. And this is really, this is a thing, this is a thing in the operating system that should be handled better in the operating system. And generally, especially for Deus Ex Mankind Divided, this is handled much better in Linux than it is in Windows, just out of the box. If we step up from 1080p to 1440p, things get a little more weird. At 1440p, the Ryzen 7 9700X starts to struggle. Look at our 1% lows. And the Core Ultra 7 270K Plus pulls ahead. Now keep in mind, I've unbalanced things here. I'm using a 5090. At 4K, I don't know why this is, but it was repeatable. At 2160, the 9700 steps back in line. Okay. But look at this. Our AMD CPUs are pulling ahead a little bit of their Intel counterparts. Now, Deus Ex Mankind Divided is an older game, but it's not one of the games that was available in the binary optimization thing. What about Cyberpunk? Cyberpunk is one of those games that are supported. Okay, at 1080p, it's the same kind of a story. The Intel CPUs are pulling ahead. It doesn't matter if it's the Core Ultra 5 or Core Ultra 7. It's very similar performance. The 1% lows are a little bit worse. AMD's not doing bad here. The 1% lows are surprisingly worse in Cyberpunk at 1080p with Ultra as I was doing my testing, but not like, it's not unplayable. Like the gaming experience here is good. When you step it up to 1440p, it's pretty much the same story with a slightly lower overall frame rate. At 4K, it reverses. The AMD CPUs pull well ahead. We basically have the same 1% lows, and we're at about 110 FPS on our Intel CPUs, and it doesn't really matter too much which Intel CPU that you're using. But if we do our binary optimization tool, it makes up the gap between the Intel and AMD CPUs, and the performance is basically identical here at 4K, which tells me that this is a game engine bottleneck or possibly GPU bottleneck. But you're still over 100 FPS at 4K on Ultra without ray tracing. And if we look at Intel's own slides, Hitman 3, 22%. And this is over a previous generation, so they're hiding how much of this percentage is the uplift from the binary optimization, but it's kind of a lot. Shadow of the Tomb Raider, especially is an older game. Hogwarts Legacy was the newest game that had, you know, that had a significant performance uplift, 16% with that. Where did this uplift come from? More consistent boost behavior, slightly higher clocks, and binary optimization. And the binary optimization uplift varies a lot per game, but the clock uplift and turbo consistency, the boost consistency, is consistently positive impact across pretty much all games, because unless there's a bottleneck in the GPU or something like that. So what about Monster Hunter Wilds? Is it pretty much the same story? The 9700X and the Core Ultra 7 are both performing the best here. The Core Ultra 5 and the 9900X fall a little behind. The 9900X because of the chiplet design, the Core Ultra 5 I think because it's only got the 6 performance cores. But all of these are over 100 FPS. None of these are a bad gaming experience. When we step up to 1440p, all of the CPUs become more consistent with one another. And when we step up to 1440p, it is almost an identical experience. You know, 89 FPS on the Intel side versus 92 on the AMD side. And we've got very similar results for the 1% lows. If you notice, both of these say 64. These are floating point numbers underneath, and so this one is like 63.6 something, and this one is like 64.4 something. So that's why it's a slightly larger graph, a slightly larger bar. But that's why, which is, you know, fun times. Anyway, Final Fantasy Dawn Trail, 282 FPS. It's like we need a little more oomph. 12 real cores, like 12 P cores and no E cores for Final Fantasy Dawn Trail. This is amazing. But if you turn on binary optimization, because this is one of the games that it will close the gap for the Core Ultra 7. So this is 1080p. If you step up to 1440p, things normalize a little bit more between the CPUs, and when you step up to 4K, it's a very similar experience. But the Intel platform does lag behind just a little bit versus the AMD platform, and that may be because of, you know, that L3 latency, or maybe that's just a benchmarking artifact in Ada64. But, you know, maybe those latency differences factor in a little more than one might expect here. But I thought this was really interesting, at least for launch day benchmarks. And if you want to see more benchmarks of a particular game or a particular configuration, you know, let me know in the comments below or in the forum, because we're going to do 2 i7 build videos as well. But let's talk more about the binary optimization tool and what's under that umbrella from the you know, Intel optimization technologies, like what they're working on. Now let's talk about what Intel is actually doing here with the binary optimization tool, because they're presenting this like it's a brand new thing, and it's not. What Intel is calling binary optimization here isn't magic. It's a modern take on binary translation and post-link optimization. Something, you know, it's very similar in technology to what we've seen before in systems like HP's Dynamo or Transmeta's code morphing software. Although Transmeta was a little bit more like dynamic. It's not quite. It rhymes. It rhymes. Most of these games were compiled years ago with CPUs that were much older in mind, and so there's CPUs that physically have fewer dispatch ports, fewer pipelines, different cache and branch predictor behavior. Those binaries bake in assumptions about instruction ordering and alignment and branching, and they just don't map cleanly onto modern, wide issue, deeply out of order compute cores. And Intel's tool effectively it looks at the binary execution and rewrites the hot path so that instructions feed better into today's front end, improves the micro-op cache, hit rate, front end stalls don't happen as much, and you can avoid decode penalties and render. You know, it's just, there's a lot going on under the hood here to make it more efficiently use the available hardware. It can also reshape branch layouts to play nicer with the branch predictors and reduce branch misprediction penalties, which are quite high on modern CPUs compared to CPUs of the past. So, in other words, it's retroactively fixing compiler decisions that were perfectly reasonable, you know, in like 2015, 2020 era games for new CPUs. I mean, it can make a big difference on modern games, just depends on how much they've spent on compiler tweaks. And so this is a little different than like what Transmeta was doing in the past, but it's similar. And of course, this is also a Windows first stack. There's no equivalent support for Linux right now. And if you're running Proton or native Linux titles, you're not going to get any of this. You know, the other downside of this is there's also implications for getting hung up in anti-cheat software. But Intel says that they're working with game companies on that, and you can't just turn this on for an arbitrary executable. So, what games does this help with the most? Well, it's mostly older titles. Intel's slides call out Borderlands 3, Far Cry 6, Spider-Man Remastered. A modern remaster stands out with Shadow of the Tomb Raider and a positively ancient game, Hitman 3. This is not a CPU hardware feature, though. This is a software feature. And don't forget about Intel Application Optimizer. That's runtime. That's a little different. That optimizes scheduling and OS configuration. It doesn't mess with the game, and you know, all of this is kind of under the Intel dynamic tuning technology umbrella, which also requires BIOS enablement, so you have to have a board that supports it. There's a lot that goes with that, but I'm surprised that Intel was able to squeeze out as much performance here even in the older titles, but they have, and it's pretty good. It doesn't, you know, it would be nice if the performance delta put Intel even more ahead of the equivalent AMD processors, but when really it just sort of closes the gap or just pushes them over the line. Oh, and that brings us to Linux. Bot, you know, as I said, is not a thing on Linux, but I thought maybe there was a way to get it to run anyway, since it's not really a runtime feature in the traditional sense. But yeah, I mean, if you get an optimized game binary on Windows, you should be able to run it under Proton. That should just work, because it's Proton. It didn't. But 7200 memory and the responsiveness of that and the stuff that I talked about with the 8 to 64 benchmarks, yeah, that's real. These CPUs are incredible value for the money. Intel is not overhyping them. And Intel isn't trying to beat X3D here. They're not chasing the halo. They're going after the volume market. And a $200 to $300 CPU for builds like this in that space, these CPUs make a lot of sense. And you don't have to have 7200 memory, which may still be unaffordable. If you follow the content that I've done closely, you'll know that I did 3 or 4 Core Ultra 7 based builds when those CPUs were on sale for around $300 each. And that's because they were a good deal. At $300, especially in this component shortage, well, I mean, they're good. And so this is great too. I'm planning to do 2 build videos with these CPUs. One is based on our MSI Z890 Tomahawk Wi-Fi. That system is going to be reasonable. You know, we benchmark with a 5090, but who's going to do a 5090? So this is going to be one of our builds, and we're going to take a look at that. Another build we're going to do around the ASRock Z890 Tai-Chi, but with the 9070 XT graphics card. And those are both centered around the i7. So maybe, you know, engage, get subscribed if you want to see those. If you're on Windows, when you're playing the right games, okay, maybe Intel binary optimization tool is useful. It's clever. It's got some old ideas with some modern polish. It really reminds me of the old Transmeta days, but a little different. It kind of rhymes. If you're into multi-core performance, these new Intel CPUs are a no-brainer. It's hard to recommend a 6-core CPU anymore when this is available. So that's basically everything you need to know for the Core Ultra Plus series CPU launch. Be on the lookout for those build videos. I'm Wendell, this is level 1. If I missed anything or you have any questions or whatever, hit me up below, hang out in the forum. Forum.level1techs.com. I'm signing out, and I'll see you there.